Okay, in this video we're going to look at the 8th part of exercise 1.36. Okay, so in part 6 and 7 you do something very similar. Now we have kind of a more general version. So what we want to do is we have this equation A1, 0, 1 plus B times 0, 1, 1 plus C times 1, 1, 0 is equal to D times A, B, C. Okay, now the way that we're thinking about this, A, B, and C are the quote unknowns, and D is like a parameter in the equation. So what we want to do is try to determine for which values of D there is a solution. And first of all, we need to, and when we say a solution, we mean find A, B, and C's that make this true. Now, there is a trivial solution if you consider the vector ABC equals 0, 0, 0. So if A, B, and C are all equal to 0, this is always going to be a solution to this equation. That's called the trivial solution, and we don't care about it, okay? Because it just kind of trivially satisfies this equation, and it's not very interesting. And we'll talk more about that as the semester goes on. So really when we say find a solution, we mean find a solution that is not this trivial solution. So in other words, for which values of D is there a solution? And for parts 6 and 7, we know that if D is equal to 2 or D is equal to -1, there is a solution. Okay, so now I'm going to rearrange this similar to how I did in example 6 or part 6 of this set of exercises. This is going to be A times 1 minus D, 0, 1, plus B times 0, 1 minus D, 1, plus C times 1, 1 minus D, equals 0, 0, 0. Okay, and this gives me a system of 3 equations. A times 1 minus D plus 0 plus C is equal to 0. 0 plus B times 1 minus D plus C is equal to 0. And then A plus B plus C times minus D is equal to 0. Okay, so I want to treat this like a system of equations. So in my opinion, so now in later classes, we're going to give a very precise and precise algorithm for solving things like this, but I'm just going to kind of do it in a very ad hoc way now. Okay, so this first equation tells me that C is equal, or sorry, that A is equal to C over D minus 1, and B is equal to C over D minus 1. Okay, now we have to be careful here. What if D is equal to 1? So we have to handle the case where D is equal to 1 independently or separately. So let's do that first. So I'm going to switch colors again to denote that. If D is equal to 1, what happens? Well, this system becomes a lot simpler. It just becomes, the first equation becomes C is equal to 0. The second equation becomes also C is equal to 0. And while C is equal to 0, the bottom equation becomes A plus B is equal to 0. So C is equal to 0 and A plus B is equal to 0. And so this equation tells us that, for example, A is equal to minus B. So any values of A, B, and C that satisfy A is equal to minus B and C is equal to 0 is going to be a solution. So we can write this as A minus A, 0. So any set of that form, any vector of that form is going to be a solution. So for example, if we say A is equal to 1, B is equal to minus 1, and C is equal to 0, that is going to satisfy this top equation here when D is equal to 1. Okay, so now let's handle the case when D is not equal to 1. Let's see what happens when D is not equal to 1. So if D is not equal to 1, then A is C over D minus 1, and B is also equal to C over D minus 1. Now we're going to take this value for A and B and plug it into the third equation there. And what that gives us is 2 times c over d minus 1 minus d times c is equal to 0. Okay, now one solution, of course, would be if c is equal to 0. But if c is equal to 0, a and b, if d is not equal to 1 and c is equal to 0, then a and b are both going to be equal to 0. So that means we have the trivial solution. So we don't care about the case where c is equal to 0. That means we can divide both sides of this equation by c. And what we get is 2 over d minus 1 minus d is equal to 0. Now I'm going to multiply both sides of this equation by d minus 1. And this is 2 minus d times d minus 1 is equal to 0. Multiplying both sides by minus 1 and expanding, this is d squared minus d minus 2 is equal to 0. This left-hand side is just d minus 2 times 2d plus 1. That's equal to 0. Okay, so this has a solution when d is equal to 2 or when d is equal to minus 1. So this has a solution when d is equal to 2 or when d is equal to minus 1. So let's review this. If d is not equal to 1, the system of equations tells me that a is equal to c over d minus 1 and b is equal to c over d minus 1. If I take that value for c, if I take those values for a and b and plug it into the third equation, this third equation here, okay, the c's cancel, and what it tells me is that d has to be equal to 2 or minus 1 for that third equation to be true. And if d is equal to 2 or minus 1, then this tells me what a and b have to be equal to. So what does this tell me? If d is equal to if d is equal to 1, there is a solution. If d is equal to 1, there's a solution. A is equal to minus b, and c is equal to 0. Okay, so there's an infinite number of solutions. Any vector of that form will be a solution. That's if d is not equal to 1. That's if d is equal to 1. On the other hand, if d is not equal to 1, there's a solution only if d is equal to 2 or minus 1. And then this formula right here tells you what that solution is for those values of d. Okay, so what this tells us is that there's only a solution if d is equal to 2, minus 1, or 1. Now, when d is equal to 2 or minus 1, this is what you solved. This is the problem that you solved in exercise 6 or 7. Answer 8, can you find another number d such that this equation is true? The answer is yes, d is equal to 1, and that's the only one. Okay, now actually this thing, d is called an eigenvalue, and the solutions are called eigenvectors. This is something that we're going to get to later, but it is a very important concept in this class, but we'll get to a very robust method for finding eigenvalues and eigenvectors and stuff like that. I know there's a lot here. I know there are some strange subtleties. Having an equation with a parameter gets confusing, but really just go back and watch this video several times if you need it.